Hello friends, welcome to our channel. In this lecture, I would like to explain another example based on the topic stiffness matrix method. See here, this is the given frame. For this frame, by using stiffness matrix method, we have to analyze this frame. So already I solved some of the examples based on the continuous beams. The entire procedure remains same, but there will be some small changes here. So I will explain here today that also. So what is our first step? Our first step is to find the degree of kinematic indeterminacy. So here in the stiffness matrix method, our basic unknowns are the displacements. For that, we are going to find the degree of kinematic indeterminacy. See here how many degree of freedoms for this frame. So degree of kinematic indeterminacy will be equal to. So at end A and at end D are fixed. Therefore, here it will be 0 degree of freedom. And what about B and C? B and C are the intermediate joints. So here you will get 1 degree of freedom, and here also you will get 1 degree of freedom, and E also you will get 1 degree of freedom. So totally there will be 3 degree of freedom for this given frame. So here if your degree of kinematic indeterminacy will be equal to 3 means you will get 3 by 3 matrices to solve this problem. So already I solved based on the general formula. I explained in what way I have to simplify this one. See here, this is the general equation. See here, this is the general equation. That one will be equal to delta equal to K inverse P minus PL. Here your unknowns are 3. So that is delta 1, delta 2, delta 3. So this general equation can be simplified in the form of 3 by 3 matrices. See here K, K11, K12, K13, K21, K22, K23, K31, K32, K33, and this P for P1, P2, P3. These 3 are the external forces, and this PL means P1L, P2L, P3L. Forces based on the applied loads. Okay. So I will explain each and every term. Here our unknowns are the displacements. Here we are going to find this delta 1, delta 2, delta 3. Our first step is to find the coordinate structures, is to assign the coordinate structures. See here, fully restrained structure and coordinates selected. See here, at end D, A and D are fixed. Therefore, we are selecting coordinate positions at 1A. Similarly, second coordinate position at C, third coordinate position at 3. Therefore, we are selecting 3 coordinate positions, one at B, 2 at C, and the third one at E. So this one will be delta 1, and here it will be delta 2, and here it will be delta 3. Okay. Fully restrained structure. What is the meaning here? Fully restrained structure means, if you observe clearly, this one here, B and C are the intermediate joints, E is a hinged support. Only A and D are fixed. But here if you observe clearly means, we are fixing the entire structure, not only A and D, we are fixing B, C and E also. So fully structure meaning what is the meaning of the fully restrained structure means, we are fixing the entire structure, okay, and assigning the coordinates at that position, okay, and after that we are going to find the fixed end moments. Fixed end moments. So what are the fixed moments for column AB? Fixed moments for AB will be equal to fixed moment for BA. That one will be equal to 0 because there are no loads applied on the column AB, CD and the beam CE. Therefore, you will get entire fixed moments for AB, CD and CE will be equal to 0. I am taking all the things here. Similarly, fixed moment for CD and fixed moment for DC, at the same time fixed moment for CE. Similarly, fixed moment for EC will be equal to 0 because of the no loading conditions. And what about B and C? So fixed moment for BC will be equal to whenever an uniform distributed load is acting on a span BC, then you will get fixed moments will be equal to minus WL square by 12. So what about here W? W is the given load, W into its length of the span is 6, which is 6 square by 12. If you simplify this one, you will get 120 kilonewton meter. In the same way, fixed moment for CB will be equal to plus WL square by 12. So you will get the same value here, which is plus 120 kilonewton meter. So what are the fixed moments here? Only you will get fixed moment for BC and CB, which is plus 120 kilonewton meter and minus 120 kilonewton meter and plus 120 kilonewton meter. You please remember these two things. So based on this, you are going to find these forces P1L, P2L, these two forces. See here, P1, P2, P3 are 0 here because of the P1, P2, P3 are the external forces. P1, P2, P3 are the external forces here. But here already I explained while explaining the beams. What are the external forces there? Whenever overhanging positions will be there, means we are releasing overhanging position and applying moment at that position. At the same time, directly if they will given any moment, that is also comes under the external force while solving the beams. But here this is a frame which comes under the non-sway analysis. Observe here, both ends A and D are also fixed. At the same time, here it will be a hinge support which is connecting to the member BC. There will be one more member CE which is connected with hinge support. For example, if there will be any vertical load C is applied, here there will be vertical reaction at support A. This will try to resist the vertical displacements of the frame. In the same way, if there will be any horizontal force applied on the frame, here there will be one horizontal reaction at the hinge support. This will try to resist the horizontal displacement. Therefore, this frame will comes under the non-sway analysis. Okay. In the same way, here if there will be any frame which comes under the sway analysis, means so based on the different legs, based on the different end conditions, and if there will be any force which is acting exactly at B. So such type of forces will comes under the external forces, means here it will be B which is acting some sway of some 15 kilonewton like that, means so we are selecting first coordinate position at B. So there you will get one external force at that position, means in place of P1 you will get 15 kilonewton as the external force. Like that, here based on this non-sway force at non-sway analysis frame, and the same time there are no any external forces applied on the given frame. Therefore, you will get P1, P2, P3 are 0 here. At the same time, what about this P1L and what about this P2L and what about this P3L? P1L means where we are selecting the first coordinate position at B. Okay. P2L means where we are selecting at second coordinate position at C. P3L means where we are selecting third coordinate position at E. Okay. You please remember these three. I will explain that also. So at B, some of the fixed moments at particular joint B. Fixed moments at B. That one will be equal to fixed moment BA plus fixed moment BC. So what about fixed moment BA here? Fixed moment BA will be equal to 0 because of the no loading conditions. Similarly, fixed moment BC will be equal to minus 120 kilonewton meter. So finally, if you simplify, you will get 120 kilonewton meter. Similarly, at C, some of the fixed moments at joint C, that one will be equal to fixed moments at joint C will be, one will be CB plus fixed moment, another will be CE plus fixed moment, another will be CD. So already you people know you will get only fixed moment for CB, that one will be equal to plus 120 kilonewton meter. Remaining two CE plus CD will be equal to 0 because of the no loading conditions. Finally, you will get this one will be minus 120 kilonewton meter and this one will be plus 120 kilonewton meter. And what about fixed moment at joint E? That one will be equal to sum of the fixed moments acting at position E. So there will be only one member connected. If there will be any other members like columns for first floor or down floor or side beams will be connected, means you cannot all these forces at that particular position. So there will be only one fixed moments at position EC. That one will be equal to 0. Means your P1L will be equal to minus 120 kilonewton meter. Similarly, P2L will be equal to 120 and P3L will be equal to 0. And external forces are 0, 0, 0. So already we find all these external forces and forces due to the applied loads. Then we are going to find this K11, K12, K33 stiffness matrices based on the structure. So already I explained here what is restraint structure. So here we are fixing the entire structure. So our next step is we are releasing that first position. If you observe clearly, we are fixing this entire structure, but here we are releasing this structure at fixity at B and applying unit coordinate at B. So what I am telling means, here if you observe clearly means we are releasing fixity at B and applying unit rotation at B. Here I am applying the unit rotation at B. So releasing fixity at B and applying unit rotation at B, which is denoted with K11. Okay, so whenever you are applying unit rotation, you will get the shape of the beam. See here, this is the shape of the beam K11. So I already explained what is K11. K11 means, you please remember in the form of F into D. So F and D. F means force, D means displacement. Force in the coordinate direction 1, displacement is also in the coordinate direction 1 only. Here you will get K21, here you will get K31. What about this K21, F and D? Force in the coordinate direction 2 due to the displacement in the coordinate direction 1. What about this K31? Force in the coordinate direction 3 due to the displacement in coordinate direction 1. So already I told you, so the unit value for K11 will be equal to 4EI by L. So already I explained how you will get that unit value based on the slope deflection equation. So here K11, so that K11 will be equal to K11 equal to 4EI. For B, connecting members one will be CB, so I am taking LBC, plus again for B connecting, joint B connecting member will be BA. So therefore I am taking two spans, some of the moments at that particular joints, means one will be 4EI by LBC plus another will be 4EL by LBA. So there will be no property mentioned in the given frame, therefore I am taking I equal to some I only directly. Here span length also will be equal to 6 meters. Therefore, 4E wherever I equal to I, length of the span BC will be equal to 6 plus 4EI, length of the span BA will be equal to 6. If you simplify this one, you will get 6 plus 8EI. Again, 2 4 times EI by 2 times. If I am cancelling with 2 times means you will get 4 by 3. Okay, so this one will be equal to K11. And what about K21? So already I told you, in the matrices whatever you will get K21, in the same way you will get the same matrices for K21 also, that one will be equal to, so whatever moment applied in the span B, the same moment carrying exactly half of the moment to its other end. For example, what I am telling means K11, so I am carrying exactly half of the moment in the span BC, that is here, this moment, half of the 4EI by LBC. So already I explained each and every term in what way you will get K11, K12. So entire procedure remains same like as the continuous beams. It is better to watch for the first video in our channel. There I clearly explained each and every terminology. Okay. So if you simplify this one, you will get 2 EI by length of the span. That one will be equal to 6 BC. So if you simplify, you will get EI by 3. So K21 will be equal to K12 will be equal to EI by 3. So why you are taking only this one? Because we are applying second coordinate position at C. Therefore, whatever the moment applied here, we are carrying exactly half of the moment to its other end, which is at the coordinate position 2. Not for A. Why? Because we are not selected any coordinate position at that position. That is the reason we are not taking carry over moment to that particular end. In the same way, you please remember, what about this K31? So here it will be K31. In the same way, the same matrices for K13. That one will be equal to 0. Why? Because whatever the moment applied at particular joint B, it will be only carried to its connected members, that is or B, BC and BA only. Not for E. E is the far end which is not connected to the joint B. Okay. E is the member which is connected to the CE or EC. Then at that time you will get some rotational moment. But here we are at the joint B. So E is not connected member to that particular joint B. Therefore, here the matrices you will get, it will be equal to 0. Then these are the forces, you please remember. K11 will be equal to 4 EI by 3. K21 will be equal to EI by 3. Similarly, K31 will be equal to 0. Then we will move to the next point. Unit rotation in coordinate direction 2 means we are releasing the structure at coordinate position 2, which is K22, and applying unit rotation at that position, and whatever you are applying, you will get here K12, K32, and the shape of the beam will be like this. Then we are discussing about this K22. So K22 will be equal to, so we are applying rotation moment at C for member CE, it will be 4 EI by length of the span CE, plus the same moment at particular joint connecting member CD, 4 EI by LCD, plus remaining member CB. Means wherever you are applying coordinate position, unit rotation at that particular coordinate, see how many members are connected at that particular joint. If there will be one more member, first floor column will be there, means you can take rotation for that particular column also. But here at a particular joint, there will be 3 members connected. So based on that, I am applying the 3 coordinate. So 3 unit rotations at that particular members. 4 EI by L CE plus 4 EI by L CD plus 4 EI by LCB. Then take down the values. EI and constant here. LCE will be equal to 4.5 meters plus 4 EI by LCD. Span of CD will be 6 meters here plus 6. So see the question. This one will be equal to 6 meters plus 4 EI by LCB will be equal to 6 meters. If you simplify by taking LCM 4.5 plus 6 plus 6 and simplify this one, directly the value you will get here, K22 will be equal to 20 by 9. So you will get some in terms of decimals also, you please take down that one as it is. K22 will be equal to 20 by 9 EI. In the same way, K32. What about K32? Whatever the moment applied in the span CE, the same moment carrying exactly half of the moment. That is half of the this one 4 EI by LCE. half of the moment, which is 4 ei by LCE. If you simplify this one, you will get cancel the terms whatever possible to cancel, then 2ei by 4.5. Again, if you simplify that one, how much you will get? K32 and K23, that one will be equal to 4.0 by 9 ei, means 4 ei by 9. So whatever the moment obtained here, that is K32 matrix, that one will be equal to K23 also. So both are 4 by 9 ei only. Similarly, K, this one, K12, okay, already I am writing here K12. So already I told you what about K21, that one will be equal to K21, no need to simplify again, you will get K12 and K21 will be equal to, already we solved that one, which is equal to ei by 3. If you want, take down half of the movement rotation 4 ei by L into half, you will get 4 by 6, again cancel 2 by 3. So finally you will get e by 3, that one. Okay, then go for the next step, which is K3, unit rotation in coordinate direction 3, means we are releasing the structure at E, we are releasing the structure at E and applying unit rotation at E, means K33. Here you will get K23, here you will get K13. So we are releasing structure at E and applying unit rotation at E. So finally you will get K33, K23 and K13. So in what shape you will get this one? So the beam shape will be like this. After applying the moment, you will get here like this. Okay, and what about this K33? So I am simplifying this K33. K33 equal to applying unit rotation, which is 4ei by LEC. That one will be equal to 4ei by length of the span CE will be equal to 4.5 meters. If you simplify that one, directly you will get 8 by 9. So in terms of 8 by 9, if you take decimal 0.44 or any other value you will get, means you keep like that only. Simplify 4 by 4.5 and keep the value whatever you will obtain there. And at the same time K23. So already I told you what about K32, that one will be equal to K23. So how much you will get here? No need to simplify again and again. Take down directly whatever the obtained values here. And what about K13? K31 and K13 will be equal to 0 because of the same conditions. B is not connected member to E. So all these are the obtained values. So already I explained all the values here. If you observe clearly, in the first step, see here, I explained all the terms. P1, P2, P3 will be 0 and P1L value, P2L value, P3L value. In the same way, delta 1, delta 2, delta 3 are the displacements. So already you people simplify all these values K11 to K33. Okay, just substitute all the values in the formula. Directly you will get the value. See here. So your delta 1, delta 2 and delta 3 values. What about this K11 value? So I am substituting all the values in the formula. That one will be equal to, so I am taking EI common for all the terms, 4 EI by L like that. So your K11 value will be equal to, that is 4 by 3. So take down as it is. Similarly, your K12, K12 and K21 values will be equal to EI by 3, means which is 1 by 3. That is K21 and K12. Similarly, what about this K13 and K31? That those are 0. And what about K22 value here? Your K22 value will be 20 by 9. Similarly, K33 value will be equal to K32 and K23 value will be equal to 4 by 9 EI. So I am taking already EI common outside, and here also it will get 4 by 9 K32 and K23. In the same way you will get K33 value which is 8 by 9 EI. So the formula in terms of inverse here, so stiffness is into inverse, P1, P2, P3 are 0, 0, 0 minus, and this one will be minus 120, and this one will be plus 120, and this one will be 0. Already explained each and every terms. So otherwise you take down this one directly, minus 120 plus, sorry, minus into minus plus 120, minus 120 and 0 here, and simplify directly by using your calculators. Directly you will get delta 1, delta 2 and delta 3 values. So those values will be equal to, that values will be equal to, so what are the simplified values here? 1 by EI equal to 109.565, 109.565. This one will be minus 78.261. This one will be 39.130. Means delta 1 will be equal to 109.565, delta 2 will be equal to minus 78.261, delta 3 will be equal to 39.130. Here we are selecting first coordinate position at B. Therefore, theta B will be equal to this delta 1. Similarly, second coordinate position at C. Therefore, theta C will be equal to delta 2. Therefore, third coordinate position at E. Therefore, theta C will be equal to this third value, delta 3 value, that is 39.130. So, these are the slopes at the particular coordinate position, theta B, theta C and theta E. This one will be theta E. Okay, because of the E joint. So, whatever the slopes obtained here, you can substitute all the values in the slope deflection equation, you will get final moments. So final moments, we are talking about the final moments. Final moments. So final moments, that is final moment AB will be equal to fixed moment AB plus 2EI by length of the span AB into 2 theta A plus theta B. So already people remember, you will get slopes at the points theta B, theta C, theta E only. But theta A and theta D are the fixed ends, therefore you will get slopes at the two positions will be 0. And whatever the values at B, C, E, you please substitute those values here. So that one will be equal to, fixed moment will be equal to 0 here because of the no loading conditions. Again 2EI. So I am taking 2EI, and what about L value, length of the particular span AB will be equal to 6 meters. I am just giving hint here, and again theta A will be 0, therefore you will get 2 into 0, 0 only, plus theta B value. What about this theta B value here? The theta B value will be equal to 109.565 by EI. Okay, after substituting all the values here, you please simplify directly. You will get fixed moment AB will be equal to 36.522 kilonewton meter. Okay, in the same way, take down fixed moment BA. Fixed moment BA. Okay, sorry, that is final moment BA. So don't confuse. Final moment BA means that one will be equal to fixed moment BA plus 2EI by length of the span BA into 2 theta B plus theta A. In the same way, take down theta A will be equal to 0 here, and what about theta B? Already I told you 2 times of the slope value 109.565 divided by EI. Again 2 EI by length of this particular span BA or AB will be equal to 6. Fixed moment BA will be 0 because of the no loading conditions. So substitute all the values and simplify directly. You will get 73.043 kilonewton meter, and go for the span joint BA BC. Fixed moment for BC will be equal to, final moment for BC will be equal to fixed moment BC plus 2EI by length of the span BC into 2 theta B plus theta C. So here you will get two slopes. You substitute those two slopes values. Again fixed moments BC will be minus 120 here plus 2EI by length of the span 2 by how much it will be length of the span BC, that one will be equal to 6 meters. EI kept common like that only. Again 2 into what about theta B? Theta B you people know that one 109.565 by EI plus what about theta C? Theta C will be equal to, already we solved that one will be equal to minus 78.261 by EI. If you simplify this value, okay, if you simplify this value directly you will get minus 73.043 kilonewton meter. Why? Because so actually no need to simplify this BC value. For check purpose only we have to simplify that one. Why? Because sum of the moments at joint B will be equal to MBA plus MBC will be equal to 0. Means sum of the moments at a particular joint means final moment BA plus BC will be equal to 0. So here you will get 73.043. In the same way, if you want 0 means you will get the same value here, which is 73.043. Means whatever the moment obtained here, you will get the same moment with opposite sign. Then at that particular joints, those moments will be equal to 0. Means MBA will be equal to 73.043 means here you take down directly minus 73.043 kilonewton meters per remaining joint, which is BC. Okay. Then move to the next point. Final moments for BC. Final moment for CB means we are talking about the joint C. So fixed moment CB plus 2EI by length of the span CB into 2 theta C plus theta B. So already you people know what about the fixed moment CB, that one will be equal to minus plus 120 plus what about 2EI by L, 2EI length of the span CB will be equal to 6. Here this will be plus 120. So I am giving the values here directly. You please take down that values. This one will be plus 120 and plus 2EI by length of the span will be 6 meters, 2 by 6 into what about theta C? So already I told you 2 into theta C value will be equal to minus 78.261. In the same way, theta B value will be equal to 109.565 by EI. So please substitute all the values whatever I am giving here in this equation. Directly you will get fixed moment for CB will be equal to, so after simplifying you will get 104.348 kilonewton meter. In the same way, fixed moment for CE So already in the final moment for CE, so already at a particular joint some of the moments will be equal to 0, but here at a particular joint C there will be 3 members connected. If you add these 3 members you will get 0, means already you will get 104 here. Whatever the values obtained at CE and EC, you will get the moments which is equal to this moment. So that one will be equal to fixed moment CE plus 2EI by length of the span CE into 2 theta C plus theta I. Here you will get two slopes. Fixed moment CE will be equal to 0 of the no loading conditions plus 2 EI by length of the span CE, that one will be equal to 4.5. In the same way 2 into theta C. So this theta C value will be equal to minus 78.261 by EI plus this theta E value. What is theta E value? So already I simplify this one, 39.130 by EI. You take down approximately 40 also no problem, or else directly 39.1 means 39 only. So you will get same value approximation in the final value, which is, if you simplify that one you will get fixed final moment CE will be equal to minus 52, means if you take approximation means some 51.9 like that, which is in kilonewton meter. In the same way, if you take down the entire formula, fixed moment for CD, that one will be equal to final moment CD will be equal to fixed moment CD plus 2EI by length of the span CD into 2 theta C plus theta D. Here slopes at this point D will be equal to 0 because of the fixed. You will only get 2 into this theta C value. Here also 2 into this value, that is minus 78.261 by EI. So I am just giving the values, you please substitute all the values. Length of the span CD will be 6 meters and fixed moment CD will be 0. Again, what is the final value? If you simplify this one, minus 52.174 kilonewton meter. Again, you see here sum of the moments at joint C will be equal to 0. But what are the sum of the moments here? Final moment CE at that particular joint, final moment CD plus final moment CE, CD, CB equal to 0. So if you take down all the values, this one will be 104.34 and this one will be minus 52.17 and this one will be minus 52.17. If you simplify, you will get these values 0. So that is the procedure to find the value whether it will be correct or not. In the same way, you can go for the next value. If you simplify all the values directly, you will get so your final moment for value MDC, that one will be equal to fixed moment DC plus 2EI by length of the span DC into 2 theta D plus theta C. So that value will be equal to, here fixed moment DC will be 0 plus 2EI by length of the span, that one will be equal to 6, that is 2 by 6 into, I am writing theta D value here, that one will be 0 and theta C value, that one will be equal to minus 78.261 by EI. So just substitute all the values in the formula, you will get minus 26.087. So based on the approximation, you will get some 25.9 or 26.1. So it is okay, no problem. You take down direct approximate values only. So this is the procedure for finding the final moments based on the obtained slopes on the stiffness matrix method. I hope you understand this lecture. Thank you so much for watching this video. If you really like this video, please like this video, share it to your friends and subscribe our channel. Thank you so much.